In this tutorial, we're going to find the Laplace transform of f of t, which is 1 when t is greater than or equals to 1, but less than 2, and 0 otherwise. So given that function f of t, I usually find it convenient to start by drawing the graph of f of t. So I'll draw that graph, and I have my horizontal axis there, which is f the t, and the vertical axis. And I have my f of t there, and I put my 0, and we have the point 1, and the point t equals to 2. And we have the point 1 there on the vertical axis. And what we are having there is the f of t is 1 between 1 and 2. So the next step now is to write that function f of t in terms of the Heaviside function. By inspection, we can see that f of t there is h of t minus 1 minus h of t minus 2. But if you can't see that by inspection, we can try to look at it by drawing the following graphs. So I'll start by drawing the graph of h of t minus 1, and I'll indicate it with a white line. So we have our horizontal axis and the t there, 0, and then the point t equals to 1, and the point t equals to 2, our vertical axis, and label the point 1 there. H of t minus 1 is the graph of h of t which has been shifted by 1 unit to the right. It is 1 whenever t is greater than or equals to 1. So we have it is a 1 there, and that's h of t minus 1. And go on to draw the graph of h of t minus 2. And I will represent it by a black line. H of t minus 2 is the graph of h of t, which has been shifted by 2 units to the right. So it will be 1 whenever t is greater than or equals to 2. So that's h of t minus 2 there in black. Let me go on and label our first graph there, where we have the f of t 1 and the second graph 2 there. What we see is in graph number 1 there, the function is 0 whenever t is greater than 2, or if it is less than 1. So to try and obtain that function there in graph number 1, we can use those two graphs in graph number 2. So what we have to do is we have to make graph number 2 to be 0 in the interval 2 to infinity. Both if we have 0, 2 to infinity there, that graph will be the same as the one in graph number 1. So what we want is, we want it to be 0 on that part that I've highlighted with those places. And to achieve that, we can subtract h of t minus 2 from h of t minus 1. So if we subtract h of t minus 2 from h of t minus 1, we'll get a 0 there because it will be 1 minus 1. And when we do that, that part will be a 0, and we'll only be left with that part between 1 and 2, which will be a 1. And it will be the same as graph number 1. So that will be our f of t. So what we are saying there is f of t is equals to h of t minus 1 minus h of t minus 2, which is the same result which we obtain even if you do it by looking at it by inspection only. But if you do these problems again and again, you'll be able to write the function f of t in terms of the Heaviside just by inspection. So we are having our f of t now. We can find the Laplace transform. So for the Laplace transform of f of t, it will be the Laplace transform of h of t minus 1 minus h of t minus 2. And by properties of Laplace transforms, that will be the Laplace transform of h of t minus 1 minus the Laplace transform of h of t minus 2. At this stage, we can now go on and use the tables to find those Laplace transforms. So from the tables there, we start by looking at that first function h of t minus 1 and compare it with an f of t which is similar there. So the f of t that we see in the table there is h of t minus c. By comparison of the highlighted functions there, we see that c is equals to 1. And we substitute 1 where we have f of s in the table there. And we have f of s is equals to exponent of minus 1 times s divided by s. and it will give us exponent of minus s divided by s. And I'll put it in the formula above there. We have exponent of minus s divided by s. We now go on to the next part there, where we are now looking at h of t minus 2. So we are now looking at h of t minus 2 there. And by comparison, we will be looking at h of t minus c there in the table. And by comparison of those two highlighted functions, we see that our c is equals to 2. So in the f of s in the table there, we substitute c equals to 2, and we have our f of s is exponent of minus 2 times s divided by s. And it will give us exponent of minus 2s divided by s. I'll then go on and substitute it above there, and we have minus exponent of minus 2s divided by s. So we are having, that is our Laplace transform there. And what we can note there is s is a common denominator, so we can just write them under a common denominator. And we have exponent of minus s minus exponent of minus 2s divided by s. So what we are having there is the Laplace transform of the given f of t is exponent of minus s minus exponent of minus 2s divided by s.